Hello, everyone. And in this video, we are going to be continuing our discussion on the implementation of various cybersecurity fundamental topics. And this video is going to be discussing about how to implement a very simple firewall simulator implemented using Python. So the first thing before we move forward is the question that why should we use firewalls? So firewalls is a very key component for implementing network security, and it helps to protect our systems within our networks from receiving any unwanted or harmful network traffic, right? So it does so by implementing the cybersecurity concepts of packet filtering, and it also enables the concept of network segmentations like we have discussed in class. The concept behind a firewall for packet filtering is enabled by certain key components that the firewall basically checks, which is essentially a program, and the program checks for these different components. And these components are essentially taken from the packet header. So if we take a quick recap of the different components that could be present in a network packet header, we have source IP address, we have destination IP address, we will have some sort of a port number, and then we can also include the transmission protocol in the form of either the TCP protocol or the UDP protocol, right? So in our simulation, the one that we are going to be implementing in this video, we are going to be taking into account a subset of these header components, specifically the source IP address, the destination IP address, and the transmission protocol. And we will be excluding the port number, but you can include this very easily. Once you see the implementation of the program using these three components, you can see how you can incorporate the port number yourself. So that will be a good self-exercise in order to extend the program and to kind of increase your comfort with respect to getting better at the programming concepts and stuff like that. So in order to create a firewall rule, right, our simulated firewalls will consist of the following four components as we discussed. So it will have a source IP address, it will have a destination IP address, it will consist of a transmission protocol that we will specify, and then finally, it will consist of an action, and that action is directly related to the concept of packet filtering. And essentially what the action will say is that whether you want to allow the traffic or whether you want to deny the traffic based on these three criteria, all right? So when we want to filter it, what will happen is that whenever we simulate any incoming network traffic, right, which is in the form of a network packet, packet will consist of a source IP address, a destination IP address, and a transmission protocol. And then our simulated firewall will consist of a bunch of existing rules, right? If there are no rules, then essentially for the best security, you can deny all of the network traffic, but then the usability will have an impact on it, right? So that means your firewall needs to have certain rules which are allowing the traffic, and then it is filtering out the rest of the traffic that you as a network administrator or a cybersecurity professional, you consider to be harmful, and you are essentially creating rules to filter those traffics out. So what will happen is in our simulation, whenever we test for packet filtering, we are going to give some inputs for a simulated packet, which will consist of these three different components. And then we will check against all of the existing rules that we have created within our simulated firewall. And the program's goal will be to render a decision, and that decision will be in the form of either allowing the packet or denying the packet, corresponding to the firewall rules that are essentially checked. So that means if the input for the filtering simulation given by the user has a existing rule in your firewall, and in that firewall existing rule, the action that is rendered is to be allowed, then we will essentially give an output that the packet has, or the packet will be allowed to reach the systems, right? If the existing firewall rules have an action for denying for a given simulated input for a packet, then the output needs to be denied. And then if the incoming packet does not match any of the existing rules, just for the sake of security, we are by default going to deny all the packets, right? Here it depends on your protocols, on your configuration protocols, but um, it's like, if none of the rules matches, then do you want to allow that traffic or do you want to deny that traffic? And 9 out of 10 times the configuration rules, for the sake of security, would be like, by default, if none of the rules matches, so you don't know where this packet is coming from, then you will basically deny that packet, right? So that kind of improves the security of your packet filtering / network segmentation, right? So in terms of the components that we will use to implement this program, and this is going to be another simplistic program compared to the previous program, like we had the port scanner, which was pretty small, right? So this program will also be pretty straightforward. It doesn't have any kind of, it doesn't require any kind of external modules, external dependencies that needs to be installed. So even from the point of view of programming, this is a very straightforward programming, right? So this is one of the better exercises for you to kind of test your skills with learning and seeing that if you are comfortable knowing the basic components of programming, right? So when we will run this program, we will give our users some menu options, right? And those menu options will be in the form of adding a new rule to the simulated firewall that we are trying to create. And firewall, at the end of the day, is a program, right? Which has some logic, and then when you execute it, it kind of renders that logic and then implements the functionality that you have written within the program. So you can add a new rule. Users can add or remove an existing rule from the firewall. We can simulate the scenario for packet filtering. So that will be another functionality that will be provided by the program. We can also use the program to view all of the existing rules that we have created and added to our firewall. And then finally, we'll create a menu option that will allow the users to exit the program, right? And the way we will implement this program is, again, in a functional way, right? Where we will have a function that will be responsible for adding a new rule to our firewall, removing an existing rule from the firewall, simulating the packet filtering situation scenario. And then there will be a main function that will provide the users, print the users all these menus and allow the user to provide the initial set of inputs that will enable the execution of these sub-functionalities that we will be specifying within our program. Now, in terms of how we are going to store these different rules in our program, we are going to be taking the help of two specific data structures. The first is the data structure for the entire firewall rules itself. So we were going to be storing the entire firewall as a list in Python, right? A list in Python, in other programs, we call it as an array. But what it will look like is basically this continuously stored memory units, right? Where each of the memory indexes or each of the memory units will essentially store a singular rule, right? And the index of a list starts from index 0. So that means if you have an index whose length is, let's say, 10, then the first index will be 0, and then the last index will be essentially 9, right? Because 0 to 9 essentially sums up to 10. And then the actual values which will be present within these indexes will be the actual rules that will be added by our users, right? Using this particular menu option, right? And then when the rules will be added, the individual values of the rules will be stored as a dictionary. So we will opt to store it as a dictionary. Now, what is a dictionary? You can think of a dictionary like a key value storage type of table, right? So where you have two columns in the dictionary. The first column are keys. We call them keys, or you can think of them as labels. And to each key, there is a value, the actual value that is associated with the key, right? So that means we can create some sort of a key value pair. You can think of it like, if I use a course number as a key, then it will have a corresponding room number where the course is assigned to be taught, right? So instead of looking for that, like searching that operation, if you store all of these details as a dictionary, then it becomes very easy to look up those different values that are stored associated to those particular keys. So that means if I look for a particular course such as CS350, right, then I don't have to write a very extensive search operation trying to find the value that is associated with that particular key, because this is a lookup operation and this is going to take constant time. So that means if I'm trying to implement the packet filtering operations within this filter packet function, I'm going to be performing a checking operation against the input for these particular inputs that has been given by the user. So that means I have to check something along the lines of user input source IP, and then I have to check if that checks out against the existing rules input IP, right? So that means for each of the rules that is present, right? So this is not input IP, but existing rules source IP that is present. So whenever I'm trying to perform this checking operation, right, then I have to go over all of the different rules that are present in my firewall. And then for each of these rules, I have to extract the value of the source IP that is present within that particular rule, right? So each of the rule has to be a composition of these three different protocols, and of course the action itself. So all of these four different components must be stored here. So if we stored it as a variable, then we would be in a bit of a difficulty, because a variable would only allow us to store a singular value, right? So then we cannot store the rules as a list anymore. So that is going to create another problem, right? So it's better if we create an object or using a class or something like this, which is basically to create a list of dictionaries, right? So each of these dictionaries is basically a abstracted form of four different values. So anytime I want to extract a certain value, all I'm going to do is refer to the key, which is kind of like a label that we can use to refer. And whenever that label is referred in our program, the program will replace that reference with the actual value that is stored associated to that particular key. And this essentially makes the process of looking for something much more easier, right? So here we will have four different keys for each rule, and this is aligned with the different components that we will be using in order to simulate these four components that we will be using in order to simulate our packet filtering concept within a firewall. So we will have an action. That action will have a string value, and that string value will either be allow or deny, right? So that's a predefined string value. The source IP will be given as an input by the user. It will have some value. The destination IP will also be given as an input by the user, and it will have certain value. These values will be corresponding to an IPv4 IP address. So that means it would have something like 192.168.20. Something like this, right? Or 1.30, something like this, right? So the user will give us some input like this, or if the user wants to, let's say, encapsulate the entirety of the internet IPv4 IP address, then it will have some value like star dot star dot star, right? So it's basically all possible values that can exist within that particular range of IP octets, right? So these are the typical types of values that will be stored for source IP and destination IP. And the protocol key will be similar to the action key. So it will have a string data type. And the two possible values that will be there for the string data type will either be the string TCP, which is the TCP protocol, or UDP, which is the broadcast protocol. So it will have either of these two values. So we expect the users to provide input within these ranges that has been defined for our firewall rule dictionary. And one thing that you can do, I'm not going to implement that in the program itself. Later on, if you want to practice a little bit more as a self-exercise, you can perform input checking. So that means that if the user enters a certain value, which let's say is not allow or deny, or it's not TCP or UDP, when they're giving an input for creating a new rule to our firewall, then what you can do is you can set up like an input sanitization functionality for your input process. And then you can check the input that is given by the user and validating that it is it is within the set of the desired inputs that you expect from the user. And if it is not, then you can prompt the user to re-enter the input by using the correct set of allowed inputs. And then if the user has given the input in the expected format, then and only then do you store the actual value within a dictionary and then append it to the list of your firewall rules, right? So that is good. That will be a good exercise to, double check and see your learning of your basic programming concepts, right? So that is the overall programming logic and the security logic that we were implementing. And of course, the detailed discussions are in our lectures that we have done. So if you need to recall that, you can check out the recordings from the lecture. So for now, I will move on to the Visual Studio Code editor, and then we will start the implementation of this program, right? So in terms of setup, what I have here is within the parent folder, I have created a new subdirectory, which I have named as Firewall Simulator. And then within that subdirectory, I have created a Python script file, which I have called firewall_simulator, which is the same name as the directory itself. And then this is basically, I have opened it up. So that is all that I have done. And now we can start working on the roadmap of our program. And then we can start the actual implementation itself, right? So here again, we do not need any kind of external dependencies for the program. So we don't need any inbuilt modules. We don't need any external modules. So nothing needs to be done. This is going to be a very fundamental program, right? So what we need is basically a data structure first to store the firewall rules. Okay, so let's do 1, 2, 3, 4. Okay, so this will store the firewall rules, and let us say that this is going to be a list, a Python list. Right? I think then we had also a bunch of functions that we had written. So we need one function to add a new rule to the firewall. We need a function to remove an existing rule from the firewall, right? We need to have a function to simulate the packet filtering operation. All right. We need a main function after this, and the main function will provide a menu for all the above operations and allow the users to give input. The main function will also, let's put it here, allow a user to check all existing firewall rules. Okay. All right, let's see what we have here. So add a firewall rules. So this will be add to the previous list in point 1. We need a removal operation. So check rule index and remove if valid index. So what I mean by this is, let's say if the total number of rules in your list is, let's say, 3, right? So that means you will have an index of 0, 1, and 2. That's a total of 3. So now you ask the user, hey, do you want to remove a rule? And the user says, yes, I want to remove the 5th rule, right? So if a situation like this happens, essentially you are in a error position, and that error is called out of bounds, right? So this error will give you an index out of bound error because essentially the user has given you an index which is not between 0, 1, or 2, right? You only have 3 indexes. So we have to make sure that before we allow the users to, or before we implement the process of removing any rule, we have to first make sure we actually have an index that has been provided against the list, which is actually a valid index, right? So that is what I mean by this statement here of check rule index. Okay. Function to simulate packet filtering is basically check user input against existing rules. Okay. If it matches, then we return the action, which is allow or deny against an existing rule. And if none of the existing rules in the list match, then we are simply going to deny it by default. Okay. You can choose to allow it by default, but that's not going to be pretty safe, right? So that's something that you have to keep in mind. All right. So let's implement this step by step. So the first thing that we need, I think I've covered all that we need. Function to add a rule, function to remove a rule, function to simulate the packet filtering, a main function that will provide all the previous options, allow the user to give input and call those sub functions. And then we will also give an additional menu option within main function, which does not need a separate sub functionality for it because it's going to be pretty straightforward. So we will allow the user to check all the existing rules in the firewalls, right? So the first things first, we need a data structure, a list. So we will call that list as firewall underscore rules, and we will initialize that as an empty list. Remember, lists are assigned or declared using these third brackets. So that is what a list is, or that is how a list is essentially implemented. So next we need a function to add a new rule. So we'll say add a new firewall rule. Okay. So we will def add rule and leave this empty for now. Okay. Just like we do. And then we will have remove a rule. So we'll do def remove rule. Okay. And we will leave this empty for now. All right. However, this will require certain input here. So the user has to give an input of which index in the list that they want to remove, right? So that means we will need a rule underscore index. Let's call this variable rule underscore index. And we expect this to be provided by the user when they try to activate or use this particular functionality in our program. Let's see, what's do we have? Then we have a function to simulate packet filtering. All right, so we can do a def packet underscore filtering. Okay, and we'll say pass. And does this function require any input? Yes, it does, right? Because I think this will be the input that is provided by the user. So whatever input is provided by the user, we need to take that input and then we need to kind of send that input to this function so that we can actually do a comparison of the input that the user wants to check against the rules that are present in the firewall. So what we want to do here, since we discussed in the the logic discussion, is that the individual rules, so we will make a comment here as well, and we will say 1.1, and we will say individual rules will be stored as a Python dictionary. All right, so in bracket, we can say key value pairs. All right, so here we are going to just name a dictionary and we are going to say packet. Okay, but this is going to be a dictionary. Right now it says any, but when it receives the value, it will receive the value in the form of a dictionary for representing the packet that the user is giving as input, right? So that is 1, 2, and 3. Simulate packet filtering, and then we have main function. Okay, so right now we can write a main function. So I'm going to break the main function down because the main function is going to be pretty big. So I'm going to define main separately before I write the if name equals main thingy. So let's just put it like this. Give a pass. The main doesn't require any input, of course. And then we are going to say here calling the main function. All right. So for calling the main function, we are essentially going to write the if else, the if part. Okay. So if and then underscore underscore name underscore underscore equals equals underscore underscore main underscore underscore, then a colon, and then all we want to do is call the main function, right? So that kind of does the tie up with this particular main function, ensures that if we run this program with the name of this file, this will essentially fire up this main function. Okay, so that takes care of the main. So let us start with the main function itself. The main function needs to provide a menu of all these operations so the users can give the input and access these functions. And in addition to that, one of the functionality that will be provided only directly from the main function, which is to allow the user to check all the existing firewall rules, right? So we'll start that off here. We'll start working on this. We'll remove this pass guide and we'll start writing it here. So let's say first we give a basic welcome message. So here you can say, welcome to the firewall simulator program. All right. And then we can say after this, please pick one of the following options. Something like this. And then we will start a while loop, and the while loop will run infinitely unless the user chooses to terminate the program. So the condition of the while loop, in order to run it infinitely, we are going to just say the condition is always true. The condition is always true. That means the loop will also continue to perform its operation forever, right? So first thing, we need to prompt the menu options. So we are going to give a print here, and then we will write a \n. So this is going to render a new line. So it's very similar to pressing your enter key when you're typing a document. So it will create a forced new line. And then we will give a menu option and say add rule. Okay. And we can say press 1, something like this, for the lack of a better prompt, or you can give a better prompt option than me. Then we can do a print copy. Let us just create the skeleton for this because we need to do a lot. So we will add a rule, then we will remove a rule. So I'm not going to repeat this press 2, but you can, for the sake of consistency, you can add this to all your stuff. Let us just copy this whole thing now. And the next option is going to be number 3. And this one is going to be simulate packet filtering test. And we can say press 3. And then we will do, after this, we will have option number 4. And in option 4, we will say show all existing rules, existing firewall rules. Okay, and here we will say press 4. And then finally, we also need to give an option to exit the program. Otherwise, the program will never stop because we have while true going on there in line 29. So here we will say exit the program, and we will just say press 5. Right, so that takes care of our menu option. So now we have to take input from the user. So to take input from the user, we will use the inbuilt input function, and we will say choose an option. Choose an option between 1 to 5, something like this, right? And this will be given as an input. So we need a variable to store the input. So we will say choice is equals to this value, right? So that will essentially, whatever the input is given by the user, it will store the value within this variable. Now we can use this variable and start running a if-else statement in order to fire up all of the sub functions that we have defined. And then one by one, we can pick and solve and implement these sub options, right? So right here, we are going to start our menu options. So let's do if, not fee, if, okay. And then we will have choice equals string value 1. The reason we are comparing it with a string is because this input is going to capture it as a string. So that is the reason why this value is compared against a string and not like a numerical one. If you want it to be compared against a numerical one, then you will have to typecast this input to integer, right? So then you will have to add an int at the beginning here and then wrap this whole thing. And now if you do this, now you can see that the value is an integer. So if that is the case, then you can convert this to if choice equals 1 there, right? But since we don't have to do this, essentially we can compare it against a string. So if choice is 1, we will, do something. All right. Elif. So we need to check the next one. So we will repeat this option. So if choice equals 2, we do something. All right. We need another elif. So now I'm going to start copy pasting this. So we will do an elif here. All right. So if choice equals 3, we do something. Leave it empty. Again, we need an elif. If choice is equals 4, we do something. And then finally, we just have the 5th choice, right? So we will again do an elif and we will make a default choice after this. So if this is there, and here we need to stop the program. So we don't have to write a pass here. We can simply write what we need to write, which is break. Break essentially will break it out of the loop, this while loop. That is what this statement is going to do. And once it is broken out of the while loop, there is nothing else in this particular function. So it will essentially stop at that point of time, right? And then we will give a default choice here, which will be implemented as an else because we don't need to check anything else. So we will just give a print option here and we will say something like invalid choice. Please enter either 1, 2, 3, 4, or 5. Okay, something like this. So that will take care of that. All right, so let's see. Everything looks good. Now we can start working on the first choice. So the first choice is to add a rule. So what do we need to do? In order to add a rule, user needs to provide inputs, and then we need to call a function, right? So essentially what we can say is 1, 2, 3, 4. We need 4 inputs from the user, which is basically the source IP, SRC IP, SRC destination IP, and then we will need the protocol for the TCP UDP, and then we need the action, right? The action is basically given this particular rule, whether you are going to allow it or whether you are going to deny it, right? And then once that is done, after this, we need to call function add rule inside of this, right? So to do that, we can simply start creating our inputs. So let's say we create a variable to store the action. All right. So we will say input method, and we can write something like enter action. And in brackets, we can give that indication. We expect it to be either allow or deny. And this will be a string, so no worries about it. We'll create another variable to store the source IP address with our input method. And then we will just say enter the source IP address. All right. And if the user wants to include all possible range of IP address, we will just say or star for any IP address. All right. So let's give a colon and space here. So it looks good. And after this, we will do the same thing for our destination IP address. So we will say dest IP address. And then we will copy this guy here and we will paste it. And we will say, instead of source, just say destination IP address or star for any IP address if you want all possible ranges of IP address to be included. And then we need to create our protocol, right? Or save our protocol. So we'll create a variable for protocol. Let's paste this input again, and we will say enter protocol. So that will be TCP or UDP. That's the two protocols that we are considering right now. Or we can say star for any protocol. So instead of saying any IP, we will say for any protocol. Okay. So that's all the input. Now we have to add the rule. So here we will call our function. So we will say add rule. That's the function. And then we will pass in all of these different inputs to it, right? So that means we will take this, and we will pass it there. So we will say action. We will say src IP. Then we will say DST IP. Then we will say protocol. And that will be a call to the function above. All right. So once that function is sent to this, so this function will then fire up, right? So we actually need to copy this, guys, because we are sending input to that particular function. So I will copy all of these 4 input arguments and I will specify them as parameters here so they can be captured. And once it is received here, the body of the function is going to be very simple. We just need to add this to the list in line 12. So line 12 for me is basically this guy here, right? And save it, save each rule as a dictionary object. Okay, so that is what we need to do in this particular. So what we are going to do is we are going to call the list, and then we are going to use a method for list, which is called append. So this will not override the existing information in the list. So that means if, let's say, in the list you have 1, so if I call append and the next value is 2, then it will simply append it to the end of the list, right? And this will continue. So this will not overwrite it. So we do not say something like, firewall rules equals, and then we assign the value. This will overwrite everything that is already there in firewalls, right? So that is why we want to use the append method so that we can add whatever new is there to the new. So if the list is empty, right? So it will just put a 1 here and then wait for the next value if there is any value, or that will be the end of it. So that is what the append will the reason why we are using append in this particular action. Now, in the append, we want to enter the value as a dictionary, right? So we'll come back to that in a short while. But if we had a variable, right? So this is what the variable would have been. Let's say if we had these values of, let's say if we wanted to enter a singular value of 1 and then a singular value of 2, 3, and so on and so forth. This is what the line of code would have looked like. Whatever the name of the variable was, which was storing that value, we will just append and push it into that particular list, right? But we don't want to store each index inside of this list as a singular variable, because you can see here, for each value within the list, that which is essentially a rule, there are 4 additional variable values that are associated with that. So we need to kind of like pack them together under a single value, right? And this is what a dictionary object is going to be helping us with. So again, if you remember, for each dictionary object, we will have a key and we will have a corresponding value to that key. So first of all, in order to declare a dictionary in Python, we use the curly brackets. We simply use the curly brackets and we are simply going to write each of the key value pairs separated by comma. So let me write the first one down and hopefully it will start making more sense. So my first key is going to be a string called action. That is the label of the value that will be stored. Now, where is the value that is associated with this action? It is stored inside this variable called action itself. So I'm just going to paste it here. For the next pair of key values, I'm going to create the next label. So let's say the next label, we call it as src_IP. And where is the value for this particular label? It is stored inside this variable called source IP. Now, hopefully you have gotten a hang of what we are trying to do here. So then we will create the next label. So I will use the same name as that of the variable. So I will say destination IP, and then I will just paste it here. And then finally, I have protocol. So I'll just use protocol. And then where is this value stored? It is stored inside this variable called protocol, which is basically the input parameter for this function. Now, using this entire rule, which will be stored, let's say for the first time in index 1 of this list, will have 4 different values. Now, how are each of these values are identified? These are identified by the labels that we have created. So that means if I say I want the source IP for the rule that is stored in index 0. So I will call firewall rules index 0, and then I will say dot, and then source IP. And then source IP that will be returning that the actual value, which is whatever this value is that is given as input by the user, right? And then let us give a prompt here just to acknowledge the fact that a rule has been successfully added. So we will just use a print statement, and we will say rules firewall rule has been successfully added, and you can check using show all rules, something like this, right? Some prompt like this, which will let the user know that their expected task is essentially done, right? So once that is taken care of, the next operation will essentially be the second option, which is to remove the rule. Now, in order to remove the rule, the user needs to give an input of the index to remove from list, and then after that call function to remove the actual content. All right. So here we need an input from the user as well. So we have already given a name to it, I believe. Yeah, rule index. So this is the variable that will be storing the user input for the index to remove from the firewall list. So we will assign this to input, and we will say enter the rule index to remove. All right, so give a space and like this. And this needs to be an integer because this will run as an iterator on a for loop, right? We need an index within the list, right? So now we will do an int casting here so that the value inside rule index is essentially an integer and not a string. So after this is done, then we can call the function, which is remove rule, and it expects an input, and the input will be rule index itself, right? So that takes care of the call to the function. So now if we go to this remove rule, then we can start essentially writing down the body. So the first thing that we need to do is check if the index is valid. Okay. So that essentially means to check if it is between 0 to n minus 1, where n is size of firewall underscore list. This particular list itself, right? So is it firewall list? What did I call it? Firewall rules. Okay, so firewall rules. All right. So if that is, so what do we check here? So we will check if the rule index is less than the length of the firewall rules list, and it also has to be greater than or equals to 0, right? So we will say if rule index is greater than equals to 0 and rule index is less than the length of the firewall. If both of these conditions are true at the same time, all right, then that means the rule is correct essentially, right? So then what will happen? Then we can actually start, removing it from the actual list. Now to remove it, we will again use an inbuilt function that is associated with lists that makes our life easier to remove it, right? So we will first call the list, which we want to modify. And you can see here, there is a lot of different options. There's copy, count, extend index. The one that we are interested in is using pop, not remove. Okay, remove will essentially, you can read the documentation description on your screen right now. It will remove the first occurrence of the value and will raise an error if the value is not found in the entire list. So that means if you have a list which is something along the lines of, let's say something like this, let's say 1 2 2 3 4 etc. So let's say if you say remove 2, so it will remove 2 from here. That is the first occurrence of 2, and then it will just, that's the end of the modification that we're doing. That is not what we want here. What we want is that given this index, it will find where that index is in the list and it will remove the corresponding value. So what we need is essentially pop. That is what we need. And to the pop, we are going to provide the rule index, right? So that will essentially be the rule. And then we can give a confirmation message here. Desired index has been removed from existing firewall rules, something like this. Okay. And then if this condition does not match, let's say if the user gives us an invalid index, then we also need to give some sort of a confirmation, and we will give here that invalid rule index. Okay, and we can say, please try again. Something like this. All right, so that should take care of our removing a particular index. All right, so let's see. Then we have, what do we have next? We have to simulate the packet filtering. Okay, that will take some logic. And the next one is show all existing. Let's do this one first. Okay, let's do show all existing firewall rules, because we essentially have to take this guy here and we have to print everything that is present in that at that point of time when the user presses it, right? So that is basically, which option is that? It is option number 4. So we'll come to 4 here and we'll start working on this guy. All right. So all we need to do in order to show all the contents in a list is loop over the list and print. That's it. That's all we need to do here. So you can write it as a separate function if you want to. You can modify my code, and as a self-exercise, you can try doing it by yourself. So what I'm going to do here is, I hope all of you remember, before in the previous programs that we used to do, we used to write something, when we wrote a for loop, we wrote something around the lines of, for any given loop control variable in range, and then we used to provide a start value and we used to provide an end value to this, right? This is how we used to run our for loops in the previous programs that we had seen. Now, the thing about the way we write this is, when we run this kind of a loop, this particular method is only going to create an index. So that means if this thing, the start value is, let's say 0 and the end value is 5, then LCV will have a value of 0, 1, 2, 3, 4, 5, right? So that is what the purpose is. But here in this particular instance, we do not just need the index, but we also need to grab the value that is present there, okay, within each of those index. So instead of using this range, I will introduce a different way of running these for loops. So this for loops, the way I'm going to write this is, when you need both the index and value in each iteration. Okay, so there is a much more abstract way of implementing that, right? So for that, we have to create 2 loop control variables. One that will keep a track of the returned index and one that will keep a track of the returned value. So let's say I'm going to call my loop control variable with a variable I, right? So I will have the values of the index, okay? And then I'm going to create an iterator called rule, and the rule will store the value of the actual firewall rules that is present in each of these indexes, right? So this in, and the method that returns both the index as well as the value is enumerate. Okay, instead of range, we are going to say enumerate. All right. And what do we want to enumerate here? We don't have to provide a starting index and an ending index because we are not creating a range of values, right? We will just provide as input the list that we want to enumerate. So what will happen here when this for loop is going to run is that in each iteration, the first iteration, let's take it, I will have a value of 0 and rule will have whatever value is present inside index 0, right? So we can print I, we can print rule, and our job is done. And then we can move to the next iteration. In the next iteration, the value of I will be 1, and the value of rule will be whatever the actual value is present inside index 1. Okay, so whenever you need both the value as well as the index, then we use enumerate, and the input to the enumerate is basically the list that you are trying to enumerate. Okay, if you are just trying to create a range of values, let's say like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, that's all you're trying to create, then you can use the range one, right? Otherwise, you would have to write the length of the list here in order to create the range of the last value. So it's a little bit of it's not that it cannot be done. It's just like this is a much more concise way of getting our job done. So inside of this for loop, we are going to print it, and we will format it as well because we need to call certain variables. All right. So when we do call it, the first thing that we are going to be printing here is the value of I. Remember, this curly bracket is not the same as dictionary. This curly bracket with the print statement is basically emphasizing the fact that we are replacing whatever value currently stored inside these variables, and that will be replaced when the print statement will be rendered, right? So a subtle difference here that you should be aware of, right? And after this, we give a colon here, and this is an aesthetic thingy that I'm doing. This is not a syntactical stuff, all right? I'm just creating some aesthetic value to the print statement that I'm giving here, okay? But now we have to essentially call the dictionary, right? Each of these values that are present is present in the form of a dictionary. So the way we are going to refer to that dictionary is, first of all, open the curly brackets. And again, this will be replacing the variable. So the dictionary's name is, we'll call it as rule. And then the rule will have the first label of the dictionary is action. So we put that action in. The next input of the dictionary is going to be rule dictionary. Okay. And then within this dictionary, we will have a value of the source IP, this guy here. That's the label that we have provided. So we will put it in the string formatting. All right. So once the source is done, and then we can give a little bit of a fancy notation here. So this is a part of the print statement. This has nothing to do with the syntax of dictionary or variables, right? And then again, we need a variable call here. And this is going to be within the rule with the label of DST underscore IP. Let's just double check that and make sure it's DST underscore IP, DST underscore IP. And then finally, we have protocol here, right? So that is the rule that we are going to be taking. And then finally, we need to give a protocol here. So let's say we put the protocol inside first brackets when we print it out. And then inside of this, again, we have to call a variable, and that variable's value will be inside this dictionary, which has a label of protocol. Okay, so that essentially takes care of our output. Okay, so yeah, that looks good, I think. Let me just see if I have named this correctly. Okay, so action, source IP, DST IP, and protocol. So action, source IP, DST IP, and protocol. Okay. All right, looks about right. We will double check this if we have made any mistakes anywhere. When we run this program, we can just check it and see if everything looks good or not. All right, so now we can focus on the last remainder portion, which is to basically filter our packets, right? To simulate the packet filtering. So to simulate the packet filtering, first we will expect the user gives a packet to check against the firewalls. Okay, so that means the user will give a source input, a destination IP, a protocol, and we will create the packet. and then we will send the packet to the function that we have set up, prototype, to run the packet filtering. Okay, so let's say src IP will be the variable that will store the value of the input. So here the user is going to say, or we need the user to give us an input, and let us give them a prompt, and the prompt is going to say enter source IP, SOURCE, source IP, and give some space. All right, then we have DST IP. We create an input again and enter destination IP. You can provide some little more supporting information that here your format must be like this and that, or you can implement input sanitization here by yourself to make sure that the user can only give a valid input and they do not give you any kind of weird input. And next we need the protocol, and the protocol is also going to be an input, and the input will be enter your protocol. Okay, so this protocol is going to be either TCP input or it is going to be UDP input. All right, and of course, allow and deny is not something that they will give as input. This is the task that will be done by this particular functionality, is that we will take these information, we will check it against our firewall. If the source destination protocol is present, then we will output the associated action to that firewall rule, which is either going to be allow or deny. And if this protocol is not present, then by default, we will just deny it. That's basically the logic that we want to implement. But first, we need to create a dictionary. So we'll create a packet dictionary. We'll call it packet. And then in order to create the dictionary, we have to open the third brackets. And then we will create a label. So we will say src IP. So we'll have exactly the same labels. And this is stored inside src IP here, separated by comma. We have DST IP, which will be assigned to DST IP that we took in line 60. And then we will have protocol. So label protocol, and value is stored inside variable protocol, which is taken as input in line 61. And that takes care of our dictionary. And then we are going to say a print, and then we will say a prompt like packet action, right? So this action meaning allow or deny, right? So in order to make that judgment, we are going to call our last function which remains. Where is it? This guy. So bring it back here, paste it here, and we are going to pass as an input argument this dictionary that we have created in line 62. Okay, so now we can go back to our packet filtering function. Where is it? Here. And then we can fill this out here, right? So whatever needs to be done. So this is going to be straightforward, nothing much to do. We just check the packet that is given as an input by the user. And then we are going to check it against the firewall rules that are present currently inside this list. If anything matches, then we will return the action that is associated with that matching rule. And if none of the action or none of the rules match, then we are just going to simply output deny by default, right? We are not going to allow by default. That is against the security functional requirements. Okay, so we need to run a loop to loop over the entire firewall. And then each time we loop, we are just going to grab the value in each of this index, right? So we need to create an iterator here. So we will say for rule in firewall rules. So simply like this, we can print or start checking what we have. So we need a big if else statement here. So let us do this. So if, this requires a lot of things, right? So let us write it down step by step. So we need to check 3 conditions. First condition, check the source IP. Second condition, check the destination IP. Third condition, check the protocol. Okay. And then every time we need to check it against a particular value or a star value. Remember, I think, yeah, if you notice here, the way we set it up is that you can give us, the user can give us a very specific IP address, or they can specify star if they want to include all of these possible IP addresses. And the same goes for our protocol, that they can either say TCP or they can say UDP. And if they want to include both, they will just give a star. So we need to check for these stars as well as the exact protocols, right? When we are running this if statement. So the condition will be for the source, the destination, the protocol, and then if it matches, then we return the rule icon. So I will just write something like this first, just to set the if else statement up. So if the condition matches, we essentially return the rule, which is basically the iterator that is going over each. And this iterator is going to refer to the action, this action that is associated to the rule that has been found. So here we will say if found, and we will leave it like this. Otherwise, if it doesn't find anything after this for loop has completely finished, so that means if the for loop has completely done its execution, that means we have exhausted and we have reached the end of this list. So that means none of the rules matched any of the existing firewalls. So here we will return, remember this is a function, so we expect to return something. So by default, we will just return the value deny. All right, so when we return the value deny, here in this print statement, it will replace this function call with whatever this function is returning. So this function will return either the associated action to the firewall rule that has been found by checking it against the input, or it will by default return a string called deny. And then this function call will be replaced with that string deny, and then it will say packet action deny. Okay. So that is how we will simulate the operation. But we need to take care of this guy here. So let us do it one by one so that we don't hopefully make no mistakes with respect to the typing. So the first thing that we have to check is basically, so we will put a first bracket here because this is going to be a very big condition here. I'm just trying to think what is the best way to write this without making mistakes, but let's just do it the traditional way. So the first thing is we'll take the rule, and what we want to check is a key called src IP. So this will change for each condition. So when we go to destination IP, we'll make it DST IP, and when we go to protocol, we will make it protocol, because these are the keys of our dictionary. All right. So what can this value be? This value can be a star, which will encompass everything. Okay. Or, so we need a logical or. This value, so that means we will just copy this because we are checking the same thing. All right. Or this value can be equals, like, and that is where we will perform the check. So we will take the packet, which is also a dictionary, by the way. So as a result of that, inside of which we will have a similar key, which is src IP, whatever value this is, right? So let us see what do we have here. Okay, so for the first condition, we are checking that within the firewall rules, so remember, rule is an item within this list, right? So that means the existing rule. So for the rules key value, source IP is either equals to this, or the rule IP's key value is equals to the one that is specified in the packet. So that means if everything is allowed, star essentially means that all input IP addresses are allowed. So it really doesn't matter for us to check what the user input is if in the firewall rule we have given a star for the source input. Star essentially includes all possible input IP addresses, right? So it really doesn't matter to have a check going on at that point of time if this first subcondition is true. So this means you're allowing everything. So I don't have to check anything after that. The or condition essentially, it helps us implement this, because the or condition, when you combine multiple conditions using the or logical operator, if any one of the subconditions are true, then the entire thing is true. So let's say if this is not star, so that means this becomes 0. So that means now I have to check the existing rule with the input that has been given by the user. All right, so this needs to match. Then we need to go to our next rule. So this is for the source. Now this needs to match for the destination and the protocol. So that means we will have two ands here. First for the destination, and then we will have another and this will be for the protocol. So now what I can do here is, in order to break this into new lines in Python, because this is going to be pretty big, right? So what I can do is I can give a escape sequence here, and I can move it to the next line. All right. and I can just place it right here. Okay, so this essentially allows me to break a continuous line of code that is going to be very big width-wise, and then we can store it. The other thing that you can do if you want to reduce such big operations is you can create temporary variables, and you can store the values in those temporary variables. So you don't have to write these big lines here, right? So here I will give another backslash, and I will press an enter here. Remember, Python is based on indentations, right? So if I had pressed an enter without this escape sequence, then it will think that this line of code has ended, but this line of code hasn't ended until we reach this particular colon here, because this is still a part of that if statement, right? So in order to break it down into multiple lines, but without indicating the fact that this statement has finished execution or it's the end of that particular line of code, we use this escape sequence, this backslash escape sequence, right? And that gives us the ability to break it down. That is one option to break down very big lines of code. The other option is you can create temporary variables that are smaller in size. So I can say, cond1, and I can store this value inside there. And then I can write cond1 equals to this, or I can take this whole thing. This will give either a true or false, right? So I can store that inside a variable, and that variable is going to be true or false, right? So then I can use that value as well. So anyways, you get the idea. So now I can copy this, and I can replace everywhere it says source IP, and I can put destination IP here. All right, so I don't need that bracket here at the end. So here I will say DST IP. Here I will say DST IP. And here also I will say DST IP. Okay, and then I will paste it one more time. Remove this last bracket from here. Here I will say protocol. I will copy this so I don't have to write this, and then I will just paste it here. Okay, so let's see what do we have here now. This is checking if the source IP is everything, or if the source IP is equals to the input of the user. And remember, the and logical operators principle is that all of the subcondition needs to be true for the entire condition to be true, right? So let's double check this. If the destination IP address is everything, or it's the one that is specified in the firewall rule, and that is what the user gives as input. And if the protocol is either everything, or if the protocol is the one that the user is testing, then we will return the action that is associated with that particular rule that is stored in our firewall. And the action is either going to be an allow string or a deny string. If we are unable to find the input of the user in any of the existing rules, then by default, we are going to just say deny. Okay. And so this function will either return allow or deny from the existing rules, or it will return a default deny. And that will be replaced here. After this function call is done, it will return a value and it will replace it in this print statement, and that should show the output. Okay, so I think we are done. Hopefully I have not missed anything. So let me just check the flow of the function real quick. So we got 1, 2, 3, 4, 5, choice input given, 1, 2, 3, 4, 5. Let's check the function call. The main function call is ready. And then we have the print for all of the different firewall rules. That is good here. We call the function to filter the packet. We call a function to remove the rules. We call a function to add the rules. Okay, everything looks good. Now we can essentially run the program and see what errors we are facing with real quick. So I'll open the terminal and I'll just say Python, and what is the name of this file? Firewall simulator.com. Okay, so runs, and let's say we want to look at all the existing rules. Right now, nothing is there. So you can see it just, shows me the prompt again. So let us add a rule. So we'll say 1. It's better if you give a white space here when you implement this. All right, so let's say we want to allow, okay, a particular input, and then we need essentially some sort of an IP address. So let's say 192.168.1.1. right? So that will be the source IP address. The destination IP address could be 10.0.0.1. Okay, that is an internal IP address, a private IP address. The first IP address is typically that of your router. Okay, default IP address for your router. Let's say for the protocol, we select TCP. All right, firewall rules have been added. So let's now press 4, which is to show all of the inputs. So you can see here the index is 0. It says allow, and then it says the TCP IP, right? So that is essentially something. I cannot even see what I'm doing because of the Zoom thingy. I'm not sure if the Zoom thingy shows up during the recording or not. But anyways, so that is basically what we have here. Let's add another rule. So let's do option 1. So we can do deny. And what do we want to deny? We can say, let's say, from any IP address that is trying to reach the IP address 0.5, where the protocol is, let's say, for a broadcast message, which is UDP, then we will deny it. And then we will click on 4 again to see all of the inputs. So you can see here the first is there, the second is there, and you can pretty up these output formats, right? That is not a very big deal. Now we can check for the what do you call it? The test for the packet filtering, right? So that is basically option number 3, right? So we need to give an input of the test packet that we want to simulate. So let's say we give an IP address of 192.168.0.11. All right, 0.11. So we have 1.1 allows to 10.0.0.1 for TCP. So we will do this, and then we will do 10.0.0.1, and we will do TCP. Okay, so the action is essentially deny, and you can check out different versions here. And the last functionality I want to check here is to remove any rules. So we have not done any of that. So do 2, and it will ask me to remove or the index. So I only have 2 indexes, so I've got to be careful. If the length of the list is 2, index starts with 0, so that means the last index is 1. If I do anything other than that, then essentially we will be in trouble there, right? So now if I press 4 here, then I can see that only one of the rules exists instead of the 2 rules. So that kind of takes care of the input. So you guys can try out many different, grouping of input IP address, destination IP address, protocols, packet actions. You can try different various combinations and see that everything is working. Try to see if you can break the program and then fix it and stuff like that. Why it will be beneficial later on is that if you can write your firewall rules as a script, right? A lot of the typical firewalls, like the Windows firewalls and the firewalls that you have in other system softwares, you can import those firewall rules as a script, right? And then you can create it instead of using the graphical interface and then clicking on stuff and then choosing a drop-down option of allow or deny. You can just program everything. So that way it is pretty good. So let us just test the last functionality, which is 5 itself, that is to exit the program. Yeah, so everything works real good. So try it out. Try out the different demos, and if you do not understand anything, you can let me know and we can clarify those things. So I will see you in the next programming video, which will probably be with respect to, I think, malware analysis or intrusion detection system, either of those 2 topics, right? So we will discuss those things, and I will see you all in the next video.